Okay, so one of the rules we look at for non-right angled triangles in trigonometry is something called the sine rule. So the sine rule allows us to find angles or side lengths of the triangles if it's not right angled. So for instance, first thing we're going to do is have a look at this triangle here in blue. So we've got X, Y, and Z. That's our three vertices. What I will take note of is the fact that the differences between the capital letters and the lowercase letters. So all of the angles are denoted by capital letters and all of the sides are lowercase letters, and each one is opposite to its own letter. So all the sides, for instance, the side B, lowercase b, is opposite to the angle B as well. So when we're dealing with the sine rule, it has a particular formula. So there's two versions of this formula depending on what we're looking for. Both will work no matter what way you do it, but it just makes it a little bit easier depending which one you use. Now this is in your formula tables book, so you don't need to learn it off. A couple of things to note here. So the first thing is that whatever you are looking for, if you are looking for a side, for instance, so all our sides are, as I said, denoted by lowercase letters. So in the first part of our formula here, we've got side A over angle A, or sine of the angle A, is equal to side B over sine of the angle B, is equal to side C over sine of the angle C. So for us, we don't necessarily need to use all three parts. Generally in a question, you're going to be given 4 or 3 pieces of information. You're going to be given, if we're using this, a side and 2 angles, and we're asked to find the second side. If I'm going to use the other version of the formula, we've got sine of our angles at the top. The reason why I'd use this instead, it's a little bit easier if we're looking for an angle. So I'd use the first one if we're looking for a side, and the second one if I'm looking for an angle. So sine of the first angle is going to be divided by the side length of that angle, is equal to sine of the angle B over its corresponding side length, and so on for sine C. So we'll never be given the 3 parts. You'll always be given 2 parts of the sine rule. So what we're going to use is we're going to have a look at 2 examples. The first example we're going to be looking at is one that's looking for a side length. So this is where we're using the first part of the formula as I've written out here. A over sine A is equal to B over sine B. So we've been given 3 pieces of information. We've been given one of the angles here that's 30 degrees, one of the angles here it's 50, and we've got a side length of 12, and we've got obviously our x, which is the distance we don't know. So first thing we need to do is look at what angles correspond to what side. So we know it's opposite. So I'm going to say this x is corresponding to this 50 degrees and this 12 is corresponding to the 30 degrees. So for us figuring out what that side length is, I'm going to say x. I'm going to put it in my top left-hand corner because that's the nice side for us to work with. It doesn't matter which one you use. But I always like to stick it on the left-hand side. So x over sine of its corresponding angle, which we know is 50 degrees. So sine of 50. And that's going to be equal to b, which is our other side length we know, which is 12, over sine of its corresponding angle, which is 30 degrees. So from here, we want to get x on its own. So we want to get rid of this sine 50 underneath. So for us to do that, we're going to multiply both sides by sine 50. So that's going to leave us with just x on this side, as both sides are going, or sine 50 is going to be cancelled out. And on this side, we're going to get 12 over sine 30 multiplied by sine 50. Now I can stick that directly into my calculator. Only thing I'd be mindful of is watch your brackets. Sometimes you can get math error there. And if I stick that into my calculator, I'm going to be getting 18.3, and then it asks me to find it to 2 decimal places. So it's going to be 18.39. Now remember, it's the length of a side. So in this case, it's going to be 18.39 units. Whatever those units are, because it didn't give us centimetres or metres as our measurement. Okay, so that's if we're trying to find a side. Our second example is if we're looking for the angle. So if we're looking for one of the angles and we have been given an angle and we've been given two sides. So in this case, we're going to use the second version of our formula. So sine A over A is equal to sine B over B. Again, we need to look at what angles correspond to what sides. So we've got our 15 is going to correspond to our angle A because that's opposite. And then our 30 is going to correspond to our 10 because, again, that's opposite that angle. So sine of our angle A, we don't know what it is, so we're going to put that over on the top left-hand side as I did for the other one. So sine of our angle A, we don't know what it is yet, but we're going to figure it out, over its corresponding side, which is 15. And then our second one is going to be sine of 30 over its corresponding sine, which is 10. Okay, so again, we want to get sine A. Well, we want to get our angle on its own, but at the moment, we just want to get sine A on its own. So what I'm going to do to get rid of the 15 is I'm going to multiply both sides by 15. So I'm going to get sine of A on this side, as the 15 is going to cancel itself out. And on this side, we're going to have sine of 30 over 10. And then we're going to multiply that by 15 as we multiply both sides by 15. Now, for this bit, we can simplify this right-hand side if we want to at this point. I would generally try and wait, but in this case, it works out as quite a nice number. It works out as 3/4. So we're okay to do that. Sine of A is equal to 3/4 or 0.75, whichever you want to use. So now we need to find out what the angle is on its own. So this is where we bring in our inverse sine. So A is going to be equal to the inverse sine of 3/4. And then if we stick that into our calculator, that's going to give us A is going to be equal to 40, and it's to the nearest degree, so it's 49 degrees. And that is our angle for A. So they're the two possible ways that we can use the sine rule. Very, very common, and it's always with non-right